This video will be looking at and continuing Chapter 12 Statistics, and we will start to look at Section 3, Measures of Dispersion. Measures of dispersion that we'll talk about range and standard deviation, and we'll also start to talk about frequency distribution, and then later working with groups. So range is the simplest measure of dispersion. So when we talk about dispersion, we talk about how far data is spread out. And so range is just the difference of the smallest value and the largest value. So say if we have a test and somebody in the class scores a 100 and somebody in the class scores a 50, and we have a whole bunch of data points in between, the range for that test is 50 because it's the smallest from the largest values. So here's an example of range, a pretty simple example. Don't let the ohm symbol throw you. It's just like F for Fahrenheit or any other symbol that means it has it's a unit value. In this case, we're talking about resistance, and what we're really looking at is 8.2 minus 1.2, and so that's the largest range, that's the largest value that we have here, and the smallest value that we have here, and our range is 7 ohms. So when we're talking about measures of dispersion, again, we're talking about the variation of the data, and so there's going to be different statistical measures that you can use for different measures of dispersion. One of the ones that we're going to definitely use here, we're going to talk about the range. We've talked about the range, and we're going to talk about standard deviation. So you'll hear that term when you look at the newspaper or look at statistics. They'll say that something has whatever the information is with the standard deviation of so-and-so. So that's basically what it is. The standard deviation, when you think about it, just think about that the smaller the standard deviation is, the closer to the mean, the average is, and the greater the standard deviation, the farther away from the mean the information is. And so remember that the mean is really important, because get that conceptually in your mind, because we're going to use that to do some calculations looking for standard deviation, and understanding that standard deviation has to do with how close it is to the mean. So take a look at this set of numbers right here. So if I add 24, 24, 24, 24, 24, then I add them all up and I divide by 5, then I'm going to have 24, and that is 24. Then the mean is minus the numbers, the data is going to be a standard deviation of 0, because there's no dispersion. They're all close. Now, if I take these numbers, 22, 23, 24, 25, and 26, and add them up, they've got a mean of 24, and so they're standard deviation is about 1.6 away from the average of this data set. It's not a very big dispersion, but it's greater than if they were all right there at the very same. Now, if I add these numbers up, and 2, 8, 21, 36, and 53, it has a mean of 24 as well. But the standard deviation is about 20.8, because it has values that are so far away from that standard deviation. So if the mean is 24, 53 is a long way away from 24, and 2 is also a long way away from 24. All right. So the deviation from the mean is exactly that. It's how far the data is spread out from the mean. And a standard deviation just says, okay, well, rather than saying that we've got one point that's all the way out here and another point that's all the way out here, and we're going to find basically that the average of the deviation. And so we can, but that's really important, because we need to be able to find the mean first. And so we're going to use this, and I introduced this earlier, what we call X bar. X bar is going to represent the mean of the data set. And we're going to have X where it is the data values. And so we're going to be subtracting a lot X bar, or the mean, minus the data set. And again, that's just like back here. That way we can figure out, we'll subtract the mean from the data set. So from 53, and we'll subtract the mean 24 from 2. And from all these values to be able to see how far it is away from the, how far the data is away from the mean for the standard deviation. Let's jump into this. So what this looks like is, if you look at this following set of data, it's talking about cubic yards of compost, and these are 8 projects that they've done, and they want to calculate the deviation, the standard deviation from the mean for these mixtures. So all that they're going to do is just go ahead and add up all of this information, all of the data, and divide it by 8. And so that's going to give us the mean. And we already know how to do that. That's the last video if you need to go back and touch up on that. Now, once we've been able to do that and figure out, and let me go back again. So notice that the mean from of this state of the composting, and so there's about 10.35 cubic yards of compost that they get. That mean, we're going to use 10.35 down here, because we are going to construct a table showing the data, and the data is the X values. Notice 9.4, 12.8, 4.5. That's the same thing that was here, 9.4, 12.8, 4.5. These are the data that you are given. Here it is transposed over here. Here's the data minus the mean of 10.35 that we got from over here, 10.35. So it's not really hard. It's just a whole lot of really just kind of what I call plugging and chugging. You just need to be able to put all your information in and then subtract the mean from each of those. What you're going to get is you're going to get a series of negative numbers and positive numbers. Well, that would make sense, just like up here. Some of these, when you subtract 24 from 53, you'll have a positive number, and when you subtract 24 from 2, you're going to have a negative number. And so that is because some of these are really far away on, you can think of a more positive side, and farther away on the negative side, away from that middle. And so when you have this series of positive and negative numbers that is going to be your X minus X bar, or your mean minus your data values. And then what you're going to want to do is you're going to want to take and square, wrong tool, square each of these deviations. So we've done this part, you found the mean, you calculated deviation from the mean. Now you're going to want to square these. What squaring these numbers is going to do is going to make them all positive, right? So a -4 times a -4 is 16, is 4 times 16. So once you get the sum of these squares, you're going to then be able to go back and subtract. You're going to be able to divide that number by n, which is the number of numbers that you had. Remember, we defined that in an earlier video. And so in this case, so in this case, we have 8 different numbers, remember? And so these are so our n is going to equal 8 for this. And so see, here's our 8 down here. But what we want to do is, this is just for the mean. What we want to do here is we want to use n minus 1 to be able to get the to be able to find the standard deviation. And then after you divide all that, then you'll take the square root. Basically, all that talking for about the last 90 seconds just described this. So just as long as you understand, you're going to take the sum of x minus x bar and square it. That means nothing more than taking this information right here, taking the sum of it, adding it up, and then squaring it. No. Okay. Oh, you know what though? I think I just said something. You're going to square all of these, then take the sum of them. Remember, make sure to turn these into positives before you add them up. And then you're going to divide by n minus 1 and take the square root. Let's see what this actually looks like. And so when we do this problem, so we're going to look at a CNA, which I know some of you out there are going to be CNAs, so this is a pretty cool example. We're looking at heart rate in beats per minute for a patient over a 12-hour period. And so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different readings. And you want to try to figure out what the standard deviation from the mean is for these different periods where they've taken the heartbeat. So over here, here's the heart rates. We've got them in a table form. Transpose them over here. Add up all these. When you add up all these and then divide by 12, you're going to get 69.5. So that's your mean for this. Mean is 69.5 when you add these up and divide them by 12. So now you're going to take your mean and subtract it from each of your data points. Okay, and you're going to come up with this series of positive and negative numbers. Now take your series of positive and negative numbers, and I want you to take these, and you're going to move those down here, or you can just make another, it's easier to actually just make another column over here. But in this case, we're going to take these, and just to be able to focus on what we're doing, and we're going to take this set of positive and negative numbers, and we're going to square them. And so notice that they are squaring those numbers over here. So it's this number right here, negative 7.5 squared becomes 56.25. Negative 0.5 becomes 0.25. Now you've got all of these numbers here. You're going to take the sum of these numbers, and you're going to use that because it's the sum of the numbers of your data set minus the mean squared, and you're going to subtract it, or excuse me, you're going to divide it by 12, or by 12 minus 1, which is 11. So your sum was 501, and then you're going to subtract it by 11, which gives you about 45.5. And then don't forget at the very end, you need to take the square root of that value, which I think is going to make sense, because if you look at this and you go, okay, well, what kind of answer is a standard deviation from the mean of 45? That really doesn't mean anything when you're looking at your data set up here of these numbers, because these numbers are about that high. And so what you want to do is you want to say, well, the standard deviation from the mean is about 6.7 or 6.8. So now we're saying, okay, what does this mean? We have a mean, so the person's heart rate is 69.5 with a standard deviation of 6.8. So that means that their heart rate is somewhere around 69.5 and either going up 6.8, so say around 77, or down to about 63, 62. So somewhere in between, so this person's heart rate ranges somewhere between, about 62 to 78. So that's, and you can see that that is the information in here. So the more data that you get, the less standard deviation you usually have. All right, and that's the end of this video.